So here we're going to talk about finding maximums, minimums, and talk about what it means for a function to be increasing and decreasing. And so what's probably best is just go through one example. I've got an example here. This is long fourth degree polynomial. And we're going to find what they call the extrema, which are the maximums and minimums. Sometimes you see it written as maxima and minima for plural. And then we're going to state where the function is increasing and where it's decreasing. And so what I have is I have this typed into Desmos already. So if we head over there we go. I've got this polynomial typed in, and we're going to take a look at this polynomial. And it looks like this. So it's kind of a W-looking shape. And so max and mins are where it has kind of a valley or a peak. And so it's fairly self-explanatory. There's a minimum right here at -1, -5. There's also a minimum over here at 3, -5. And so there are two minimums. They are, those 2 points that I just stated. And then a maximum value at 1, 3. Now, the graph goes on forever up on the left and on the right. So the absolute maximum is infinity, but this is called a local maximum at 1, 3. So let's talk about how do we write this if you were going to write what the maximums and minimums were. So let's head to the next slide, sorry. So the local max is going to be 1, 3. So let's write that out. 1, 3. So that point is the local maximum. Sometimes you will just see it, you'll say the max is 3 if they're just talking about the y value. The local min is at -1, -5, and at 3, -5. These are both considered local minimums. The absolute max is going to be infinity. Some textbooks you might see it say none because there isn't one highest point. Some textbooks you'll see it say infinity. And then the absolute min is going to be at -5. So you could either write one of those 2 points or you just say the y value, which is -5. The local min also happens at -5. So we could write that in, I think they do it in brackets. So then we're going to talk about when is it increasing and when is it decreasing. And so this is something where you read it like a book, essentially, left to right. And so let me grab a color here. Let's use yellow. And I'm just going to grab a line. Let's drag it left to right. And so think of it as like you're riding, whoops, I don't want that. There we go. Think of it as you're riding a roller coaster. So here you're going super fast down. We're decreasing on the roller coaster until we get to that minimum point, and then the roller coaster starts going up. And so now it's increasing, increasing, increasing until we get to this maximum point, and then it's decreasing, and it's decreasing to the minimum, and then it's increasing forever and ever. So what we're going to do is I'm just going to jot down on the graph, this is decreasing, this is increasing, this is decreasing, and this is increasing. And if you're taking notes, this would be a marvelous time. I probably should have warned you before to pause it earlier, but if you didn't pause it and jot this stuff down, this would be a great time to do that. Just sketch the graph, write down the local max and local min, and then resume the video. So where is it increasing? Well, it's increasing. I'll highlight it in, I'll highlight it in light blue here. It's increasing from -1 all the way until you get to +1. And so for increasing, we're just looking at the x values. We're saying from which value to which value is it increasing. And so it's increasing from -1, and we say -1 is less than or equal to x, is less than or equal to +1. And so that's one of the areas where it's increasing. And then the other area where it's increasing is from 3 up to forever. And so this will be increasing forever this way. As far as we go to the right, it will always be increasing. So we would say x is greater than or equal to 3. So these are the two intervals where the function is increasing. So then let's switch over to, I don't know, we'll go orange. It's decreasing forever on the left until we get to -1. And so what we're going to say is x is less than or equal to -1. That is one of the intervals where it is decreasing. It also happens to be decreasing between 1 and 3. So this chunk right here in orange that I'm highlighting right now, that's also where it's decreasing. So we would say 1 is less than or equal to x is less than or equal to 3. And the way that increasing and decreasing are defined, especially in calculus, is if you grab any 2 points on this interval and you find the slope of the secant line, will it be, increasing or decreasing? And so that's why it is less than or equal to and not just less than. It's a very minor technicality, but just wanted to explain why you include those inflection points where it changes from increasing to decreasing, those max and mins. So that's pretty much it. I mean, that's really all you need to know. One thing I do want to talk about, I've got another example right here. I just sketched a graph and didn't do this in Desmos, so it was a lot easier just to sketch one. And so if you have a situation like this where the maximums are not on the same level, if you look at the example before, these minimums were at the same y value. And so there wasn't one that was necessarily a local and one that was an absolute. So I just want to kind of show you that real quick. So the local max would be at -3, 2. That would be the local max for this one. Or you could say 2. The local min would be at 2, 1. Or you could say at 1. I'll be honest, I don't know if they use brackets or not, but it seems like the right thing to do. And then the absolute min is going to be -infinity, because it's going to keep going down on both sides forever. And the absolute max is going to be at 5, 5. That point where it's the absolute highest on the graph, you would write that as the absolute max, or you could do just the y value. So whenever we're talking about the max and min, the extrema, you're focusing on the y value. Whenever you're talking about increasing and decreasing, you're focusing on the x value. So that's it. That's it for increasing, decreasing, and extrema.